All right, we're live. I'm sorry I was so late. Uh, I had to pick up a trampoline, believe it or not, and in the end, it did not fit in the car. And when it did not fit, uh, uh, and when it does not fit, you have to think of something else. So I figured out I would put it on a bike and ride my bike back. So I had my wife come over with the bike, and it all worked out. But I ran very, very late. So apologies for that. So let me get set up, and we will get under our way. Yeah, normally I have this very nice intro, so I currently do not have a very nice intro. Where we left off last week, we had a beautiful application running in using database. I need to open up the chat window thingy. Where is it? Events. Yes, I'm live here. I know this. Yes. And then I can open up the chat by clicking. Yes, there we go. All right. So we have the chat. There we go. All right. Beautiful. And go to the watch page. And then one thing I always like to do is to go to Reddit and to go to the Watch People Code page. Watch People Code. And then have some viewers come in from over there. So let's explore testing in a Clojure. Yes. All right. Today's episode will be all about testing. And we talked about this last week a little bit. And testing is quite an interesting subject, but can also be a very tedious subject. So I thought about it this week, and I figured what we will do this week is to explore the different ways of testing Clojure code. There's actually multiple ways to do it, or multiple techniques, if you will. You have the plain test a function, then we can mock something, but also something that has become very popular is to do property-based testing. So I figured why not take the time to go through those three areas. We'll use the normal testing for just a plain function. We'll use ring mock for the APIs, because we have two API calls that we can mock out. And then we will pick one and do some property-based testing on it. And that should be quite an introduction for anybody who has not done any testing code really. So I found some, you can see some of my research that I picked up last night to see what would be a good thing to do. And while I'm actually warming up again, it's so cold outside now. Let's check out what is what we shall do first. Let's just first start at how you would do some normal testing, some normal assertions in Clojure. That is done with the Clojure test library. That's all fine. Clojure test. So there's actually some pretty good documentation on Clojure test. And the most important thing is that there's only basically one function that is and that has a result or checks an expression, and that expression should be true or false. If it's false, it would result in a test failure. If it's true, it will result in a test success. So let's have all the REPLs connected. You will connect. Beautiful. Worth noting is that most of the stuff works in both Clojure and Clojure script. So the beauty of Clojure and Clojure script is that you can exchange both at any given time. So the beauty of it is that it will be the same syntax and the same inner workings, while on totally different platforms. We tested with Phantom.js all the way back in the first episode. So let's just start with opening a test project. We had this core test already set up from the first episode, that afterwards we clean it up. But what shall we test? I'm still warming up, so my fingers are still a little bit. Well, we have a couple of things, right? We have a system which builds the system based on all the components. And then we have all the individual components, the connection pool that actually talks to the database. So that would be more of an integration test when multiple components do the same thing. Let's increase the font a little bit. Beautiful. And we will open up the command window so you can see what commands I'm running. CLM open command log buffer, and then it will show the commands right here. So the connection pool, the system core itself does not do much between except for starting and stopping. So those are not. There's not a lot of profit from testing those things. We have the protocol, the in-memory database, the PostgreSQL database connection, and then we get to web server. And web server has the API, the get and a post, and it has a couple of functions. In this case, the build course list. So let's take a look at what the build course list and the actual API, how we can test those. Because the change that we will make in the coming session will be to add users, authentication. So we will change the API, and we can we will change the data model a little bit, but most importantly the API, and our application on the front end is dependent on the API. So if we have that tested properly, we can make a lot of things work nicely, I think. So let's first start with just build course list and take a look at how the normal Clojure test code would actually work. So how does it know what to test, what namespace to use, etc., etc. When we set up our project, we created a source folder and a test folder. So in the test folder, test, CLJ, trivia, we mimic the structure of our project, and there is a convention that says that web server.clj will have a synonym, web server underscore test.clj as the namespace for testing. And you will see that now we have trivia.webserver-test. The underscore is automatically translated into a dash. It will have a require, and there's two important requires. So first is the trivia.webserver as SUT, and SUT stands for system under test, and the Clojure test st. So this means that everything that we need to test is imported from the Clojure.test namespace, and we would have to prefix everything with a T. Sorry. So the dev test testing and the is would be part of the T namespace. I like to import these methods themselves. So we can actually add a refer to the require statement, and we say def test testing and is will be part of the namespace web server test. And that means that we can say, well, I want to create a test. And if you see, there's within the code completion will tell us dev test part of Clojure.test, and this method. Dev test, and the documentation for it is quite with test. Yeah, so here we go. The documentation tells us it just takes a symbol basically, dev test, and we call it build course list. And now we can do our statements. So we could say the is, and that equals, if we do 1 and 0, you can see it work. So if we do 0 equals 1, it will return false. Is will then return false. And so if we do the CTT, here we go. Did that just happen right now or not? CTT? Ah, there we go. That's what I was expecting. I must have mistyped something. So when we run the Cider testing code, we see that a buffer pops up saying test summary and 1 failed, and it tells us the expected value and what we actually got. So that's all nice and dandy. There's a very nice flow to it. So we can just do run the CTT command, and we will pop into the buffer that has the test summary. So, and if we do a 1, which is what we actually want, we do CTT, the CTT. There we go. We see that the Cider code says, well, that's all good, that's nice and dandy, and that is beautiful. So now we, if we make our screen a 2-pane-1, we see that we want to, we can actually move this out of the way, we don't need the documentation really. So we want to test this build course list. One thing that we did not do very nicely while building it is we did not add any documentation, and so we currently have to figure out what it does. There we go. I'm warming up a little bit. There we go. All right. So let's first say that what we expect to retrieve when we pass it no values. If you see here, if the input is empty, then it should return an empty vector. So that's the first thing that we can test and say input, and the input that we want is from system under test, and we have this build course list function, and we want to give it a 0 input, nothing. Something that is empty, we know that we what we pass along to this function is a variable from the environment, which is a string. We do not enforce that here, right? There is a movement in the Clojure world to have something called Clojure spec. It is part of Clojure 1.9. We're currently at 1.8, and the spec allows you to actually really define what this input is, and it's not a static typing, it's more of a metadata check, I guess. But we don't have it at the moment. We did not add it. There's other techniques to actually define to make it more a type thing, but for now we know what to do. And if we document it later on, it would be much better. Well, actually, you should document when you write, but we did not do that. All right, so we call build course list. We check if it works. So it returns an empty vector. This returns true, and this returns true. So if we evaluate the entire thing and we run our tests, and you see that it runs magically. Now, there is this option within test to run tests after load file. So let's turn that on, and what that should do, I think, whenever we evaluate the buffer, it will run all the tests in that buffer. So for us, that is nice right now. All right, so we had a check for emptiness. I wonder if it works for nil as well. We did not check that, but that works beautifully as well. Well, and then you get the idea. So if we, what we will get when we add something to it, and it should be a comma separated list that we know here with comma. So we have Arjen and test. We know it should result in a list or vector of two regular expression patterns, Arjen and test. Oh, and that's my arms passing out. There you go. You see what it should do, and we can add that as our expected result. And so that should be true. It is false, so there's something else. Arjen test. That is interesting. So it thinks it is wrong while it is the same thing. That's interesting. So if we run it, let's see what it thought it got. And apparently it does not like comparing the two lists. Maybe it's the regular expression patterns that are messing it up. So let's check what would happen if we would compare a list of a string with a string of a. And that's true. So there is something odd with lists. Maybe it barks out. That's interesting. That is very interesting. I did not expect that. So that cider eval and replace. Yeah. So if we eval it and we replace it, it is exactly the same thing. So our check in this case does not work. And we need to figure out some other way to test this. I wonder if instead of doing the regular expression, this actually works. No. That is interesting. I did not expect that. See, there you go. Testing is not an easy thing to do, because you run into areas that you normally would not run into. I wonder if if it has something to do with the regular expression patterns. So let's check if this thing. So yeah, I'm pretty sure it has something to do with the regular expression patterns. Because if you compare the result of both items, it fails miserably. So you would expect that to be identical. So let's quickly ask. There's no Clojure compare list vector. Probably list will be a more common asked question. Of pattern. So, compare. Would compare work? I wonder if that works. So you find out something new every day, right? And I thought I would pick a very simple one to start with. Yeah, so probably it fails miserably due to the pattern Clojure compare pattern. No, that's Clojure pattern. This repattern. So repattern returns an instance of Java util regex pattern for use, e.g. rematcher. So it probably has an object that it is trying to compare, and that within Java an object has this equals method, and the equals of pattern is probably not what we expect will work with the equal sign. So Java pattern equals. Yeah, so not the only one. Yeah, so here we see the same thing only in the Java world. So there's this pattern object which is being created, which is basically the same as the we can eval and replace. So this thing, as we see it in our buffer and in our result, is actually an object called pattern. So what it says here is that if you have two pattern objects and you do a compile of the pattern, which is basically what this is, if you compare, just call the equals of one pattern to the other pattern, it will return false. If you call pattern dot equals, then it works. So we have this very interesting thing in that we now need to figure out how to call pattern on a regular expression. So if we do this, what will be the result? Yes, okay. So as a regular expression string thing, the hashtag with a string behind it compiles into a pattern object. We can use the Java interrupt to call the pattern itself, and that will result in in the pattern being used. So if this would be a.star, we can compare the pattern that is being called. So knowing this, what do we need to do to make sure that whatever we have here, which is the result of this function, is checked for this? So we would need to map. Would we map over it? So let's think about this, right? So we have we basically have this result list here, and now we know that we want to call dot pattern on it. So map dot pattern on the object that we pass through it. So that would be this. And then we would get a list of Arjen and test, I guess. Yes, so, oh, not too enthusiastically. So if we tell it that we will now expect a list of Arjen and test, and now we can be a little bit smarter, because now we can just say that we have a input, which is Arjen and comma test. Then this should be the same string split input on the regular expression. There we go. Yeah. So given the list of data, given the list of elements, we will get a list here. So if we do a comma b here, and we evaluate it, we get a vector of a and b. Okay, so we're getting there. We get a vector of a and b, and that should be the same as into vector map, and here we call the pattern on the object here of build course list input. And the interesting thing now is that if we think about it really hard, we could probably find some form of character combination which might be an invalid pattern or whatever, which will result in a bad combination. Let's see. So if I did this right, we now have 3 assertions that work. So now we have figured out a way. Oh, keyboard broke here, right? We have figured out a way to compare the pattern being generated by build course list to what we actually expect. And now you get into the problem space that Clojure test check tries to solve, because we tested our code now, right? We have an empty list, we have a nil input, and we have some form of input that we check to them to be truthy, but there's probably some combination of characters that or some length of string or whatever that will result in something that we do not expect. Perhaps having multiple commas. Oh, seriously, Arjen. Multiple commas behind it. Yeah, that works, but or some weird text. Save it, please. It still works. So I think that the code is quite robust. It's not very difficult, but let's suppose you have a more difficult scenario where you want to try different permutations of the input text. Then that's where Clojure test check comes in. And Clojure test check basically generates a whole bunch of information, input data. So if you have numbers or strings, it makes a large sample set of it, and then it runs your code. And when your code breaks, it tries to reduce the set that generates the failure. So suppose you have code that fails whenever the number 100 is added to it or is inputted to it, but you use this code with a counter, so every 100th execution will fail. Using test check, it will generate random numbers, and then it will automatically, due to the large set of data, it will hit that 100, and your code will fail. And then it will start trying to reduce the set, and then saying, well, if I try the first 10 numbers, Does it, or first half of the numbers, does it fail then? No, let's try the second half of the numbers, it fails, and then it reduces the set down to the most minimum set that will fail your code. And you will be much more tested than whatever you can think of, really. It would be very hard to write all those code, all that test code by hand. Man, I have a really hard time talking right now. My coffee is gone. All right, so we'll get to mocking later. Quick check for Clojure. It's actually a library, so let's add it. org.clojure.test.check, and there's also generative, which we might need, 090. That is the latest one. So it is added, and it requires quite some, you need to think about it. Probably needs the generators as well. So let's just first add it to the namespace. Clojure.test. Well, it has the generators already. Test check. And we will also add generators and properties because they seem to be used all the time. Clojure.test.check.generators gen. Clojure.test.check.properties as prop. There we go. So now we have these sets, and what it basically does, there is this. Let's first just use the basic one version. So basically, you create a thing. In our case, it will be a test, but in this case, it's actually a method, function or definition actually. That says for all properties, and a property being something, a vector of ints that is randomly generated, execute this code to see if it is truth or not. And then the test check, quick check, will run a sample of 100 on using this definition. So it will sort 100 vectors of random integers, and it should be successful or not. So in our case, if we take a look at what we want, we do not want integers, we want a string, right? So in the gen namespace, it is probably not a method. Let's see what we have. Gen bytes, gen char, does it have a gen string? Gen string alphanumeric. What does this do? It fails. Cannot be cast. It is a generator. We need to have something that calls the generator. This is gen any? No. Not empty. That's a function. So that generates a function. Okay. There is probably something that we can use right away. Gen not empty, yes. Gen factor. Here's the dev test integration. String. No, it does not have. To learn more, check out the documentation links. Let's see. Blah de blah. This is a generator. We don't need the generators at the moment. Cheat sheet. Cheat sheet's always good. Gen sample, let's try that. Sample, what does this do? There we go, so it generates a sample of strings. As you can see, it is very, it generates some very interesting strings. And we can say, gen return. Actually, I think we would want to have a, we need to actually create a generator because we want to have a comma separated list. There's no such thing. Generate. Did I do it wrong? No such for okay. Generate. Sample was fine. Because if we have a vector of strings, we're pretty close with the vector of strings, right? But we want to have it comma separated. So this would be a generator, and then we say gen sample. So give me a sample of vectors of strings. And what we actually want is to have not a sample of vectors, we want to have a sample of strings that are combined with a comma. So I guess we need to write our own small generator, which is quite nice. So this test case, however small it shows a lot of information. So how do we have a generator? So here it talks about generators, the sample, take one, blah, 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 compound generators. So we have a vector, which is a compound generator. We can create maps, but we want our own generator. Record generators, that's fine. Recursive generators, wow. How do you create your own? I would think this documentation would say how to make your own generators. Let's first with a sample, that is fine. Ascending generators. In order to write our property, we'll use generators. A generator knows how to create a random value, just namespace, blah blah. So we can combine our sample set, right? But we need to know how to make a generator. Interesting. So let's take a look at how the gen string thing is made. This is the beauty of Clojure. All the libraries basically have their own source delivered with them. So we don't know how to do this. The documentation is either we are not looking in the right place. Generator writing. We're actually at the generator writing code. It does not tell us a lot. Oh, right. Generator examples. Here we go. Dev languages, gen sample. All right. So basically, what does it do? How do you create your own? I do not know. So let's figure out. Generate strings may generate unprintable characters. Vector of car. Jeff. This fmap. So the fmap, what does it do? Fmap calls the function on that thing, right? Yeah. So string ASCII. That is beautiful. String join, right? So basically, would it just call? I'm thinking it would call, so we say vector, where's vector? Gen vector, blah, 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 blah. Vector takes a generator. So, and the generator. Oh, there it is. And a generator, what is a generator? So this vector has a generator. This car is basically a generator, and that calls another generator, which is choose a number between 0 and 5, and then it maps over that. So if we have a generator, what does it do? The def is calls an fmap. So I wonder what the result of this is, right? So fmap is a it generates a function. So let's take a look at documentation for Clojure fmap. Fmap is fmap part of this? Fmap, gen fmap. All right, so there's a. Okay, so there is a function called fmap, and that calls asserts that what we pass it is a generator, and generator is defined as an instance of generator. Okay. So there's a make generator, and a generator will take a generator function. So, oh, this is quite interesting. I've never done this before, so this is quite nice. So there is a gen make tc make. No, I'm totally generator. Oh, it's private. It is private. Gen pure. No doctor. Yes, does not have any documents. I know this. Gen fmap. Clojure test check create custom generator. Google is your friend, or DuckDuckGo in this case. Given length. Oh, that's nice. Gen fmap. Let's take a look at. Let's use this real quick. So this guy or girl, who is it? Mohawk, says that if you just do this, you will get a string of certain length, and length will be, let's say 10, right? And we want to call gen sample on it, so that we get something. So okay. So he says you can create your own generator, a simple generator, by saying gen fmap. We call gen vector, and we should call gen sample on this, of course. So if we call gen sample on this, it creates a list, of course, but we don't need this. We need a sample of a gen string. That's what we want. We don't care about. Do we care? No, we don't care. We want a sample of strings, and it's always this a certain length, right? So I guess the sample will always do 10. The gen fmap will make sure that our list of samples is the same, I guess. So if we do this and we say gen string, what does this do? Yeah, so now we have basically we have created a generator that generates a list, a string. So if we now say, give me a vector of this, gen vector, apply string. Yeah, but we would like string join or something like that, right? Would that be a string join? Is there a string, beautiful, join, yes. So instead of the apply here, for string, we would call string join on this. I don't know. No. Wrong number of arguments passed, because this is string join on a comma, something like that. Oh, look at that. Look at that. So now we have, I think we actually have something. All right. What did we do? We now have a generator that takes a vector of strings, and this vector of strings will be a certain length, and that, which is a generator, of course. Yeah, and a generator, it starts by doing 1 and then 2 and then 3 and then 4 and 5 and 6 and 7. And so it starts with 0, 1, 2 elements, 2 elements, 1, 2, 3 elements, 0 elements, 1, 2, 3, 4, 5, 6. I guess we can see, of course, get sample int. You see that it becomes broader over the length. So if we do sample of 100, is 100 like that? No, probably the other way. 100. So you see, as the collection grows, it will have a different, have a wider range. So the same goes for our newly generated generator, which takes a vector of strings, combines it into a comma-separated list, and that will be one element in a sample list. So our nice generator, let's move it up here, and let's say def CSV string, and that will be our generator. And then we should be able to say, hey, give me a sample of the generator CSV string. And then we get a beautiful vector of comma separated items. And as you can see, that it is Unicode strings. So there's a lot of unreadable garbage in there. But our application needs a list of URLs, and URLs can also be Unicode. So you can have Arabic or probably even emoji based URLs. It's hard to type, so most people don't use it, but the possibility exists. So let's be prepared for the future, and let's just say we now have a generator of for CSV lists. Awesome. Never did that before, so I'm a happy camper. Learned something new. And let's get back to our main project area thingy. Where are we? All right, we were going to test our code. So now what we want, we can basically close this window and then move it in a little bit so we have some more room. Then we move this one to the side, so we're done. All right. Okay, let's do a prop for all thing and see what's going on, right? So we have prop for all, and we will take a string s, which is a gen. I would think that would be a generate or something. Any CSV string gen any. What does it do? Nothing. Would be any value, I guess. See. Any is not what we want. Call gen, maybe choose map. We basically want to call it once and then have the quick check deal with the sizing of it. So I would think that would be a very easy call for this. Maybe it just takes the generator and we can just leave it at that. No, gen not empty generates a value, which is not what we want. So we need to have something that calls it. This is quite annoying. String, don't want that. Oh, my screen is, I think my screen is dying. It's flickering. Any call gen. Would that be what it does? Call gen, get one value? No. This is odd. That would be a very... You would think that it would just run once. It should not be difficult to just one off this function. Collection of generators. Yeah, no, that's not what we want. Seriously. It cannot be this hard, people. It cannot be this hard. Random return. There we go. It could not be this hard. So we have this prop for all already, and just move it here. And then what we want is that basically our test here. We want to check this one, right? So this is our test, but instead of having our input, it will have the s as a value, and then same here. And then I'm quite curious what this does, right? So this is prop for all, and we will def it into D for now, and then evaluate it, of course. And then we call test check. There, quick check. Let's do a check of 100D. And it has a beautiful error. Clojure test generator cannot be called. So this is not the gen return. Is not what we want. We want a not empty, no shrink. One off. Let's first start with not empty, which would be, I think, what we want. Yeah, yes, beautiful. All right, so our code now ran, and the not empty CSV generates. It's basically a generator, and it will just call. I'm quite curious why we don't have something that will just run. And what we see now is that our application cannot deal with all the things the gen CSV string puts into it. all the escape sequence, the star, it is not a valid regular expression. So that is quite what we expected, really. Let's call our CSV. I changed it to string ASCII, so we can say gen sample CSV string gen series sample. So now it is a more CSV like normal people string, basically, without the Unicode, but it will still fail because the code will, there we go, the dangling meta character near this area. So what is happening is this treating the string as a regular expression, and this will be very useful for us because we can say check anything that starts with demo or ends with demo.com and have all the subdomains be there. But then it means that we will need a generator for regular expressions, and I don't know if that exists. No. Pattern? No. So what we need is a string which will be valid for regular expression or to escape the string. So for now, let's just see if we can pass it along a set of characters that we actually permit, and if there's invalid characters in the input, it will fail. It will throw an exception, so we know our code, our application will not start, and will tell the user that there is invalid data. So now we just need to create a string that consists out of a subset of data that we allow, which is quite interesting again. And then we get into the, if we go back to the definition of this vector, character alphanumeric, vector of car, and we found vector of car somewhere above here. fmap choose car, choose 0 to 255. That is what we found earlier. So, and that is in generator, I believe, generators. So that would be gen/choose, and gen sample. Just give me some, it will give you a value. So let's take a look at I wonder if the Clojure generates string with given cars. Create a list from a string. H_z, range int I, right? This basically what this is also doing, mapping car onto a number, and that number. Here they limit it to the int value of A to the int value of Z. If we look at ASCIItable.com, internet works. So what does that mean? It is that it goes from decimal hexadecimal 61, so it would probably be decimal 97 to decimal 122. 97, 122. And then we can say we move this one wonder what this does. If we just add it here, would it just create a list? Yes, it creates a list, and then we need to map this car to this. Arc to okay. It's probably then an F map again, right? F map, yeah. F map. And F map does not exist. Gen F map. Right. There we go. And now we have a very nice situation in which we generate strings that are 1 character long. But it will actually work for our situation right now. So we can test our code with this real quick. Let's evaluate everything. So now we see that it ran 100 times and it found no errors, while previously it would fail on the first set. Let's make sure that it fails. Let's do the gen string here back here. We know this fails. This should fail. Hello. Right. This fails, right? This is the result that we want. But we want it as part of our test sequence. So now we will work with the failure case, and then we will fix the failure case, right? So what's time? 11:39. We've been at it for an hour. Okay, so running out a little bit. What we want to implement it in Clojure test. And the macro, it says here, the macro Clojure test check Clojure test /dev spec allows you to succinctly write tests within the test runner. So first thing to do is to add a require to Clojure test check dot Clojure test CT. Why not? And CT will have dev spec. And it will contain a prop for all, so that's all this part. So we do ct/dev spec. It will take a name, CSV string testing, and we will use 100 iterations, and this will be our test case. So we can get rid of this. So if we now run our code. Oh yes, beautiful. It fails, and it fails because the on-caught exception, not in assertion. Oh yeah, that's fine. But our test case fails. This is exactly what we want, and it fails because our generator generates data that is not valid for our situation. Let's quickly check if not some good Samaritan Clojure test check generate repattern. Compose generators, writing a fuzzing API, blah blah blah. Generates regular expression, regex in Clojure, yes, the chuck. Strings matching a regular expression. Macro to create a regular expression, right? Repattern this. Alright, yeah, okay. So that's not entirely what we want. Generate regular expression. Yeah, so let's first fix our code. And what we want is to have exactly this, but a little bit differently. We want to have this, but, and we want to have a gen vector of items. This should now give us random length strings or nothing. Can be cast. Yes, of course, because this is not what we want. Gen vector. We want a vector of the result. And now we still have single length, and which is basically because this is a generator in a generator. It's quite interesting. But given this, let's ensure. If we run this code again, it fails now because I don't know how to create an I sequence from character. Oh, that's interesting. Maybe we can just do this. Let's make it a string. String works. All right. And what we see here now. Oh. So, okay. Let's first apply car to this. There should be a list. Oh, interesting. What you see happen if we call the string on it, it works, but it generates a string of characters, string of numbers, which is not what we want. We want to have a list of strings, and now it says this just worked, didn't it? Yeah, don't know how to generate a sequence from character. Will this fail? This fails. Alright, so somewhere over the rainbow we've messed up. Gen sample, gen choose, right? 1, 2, 3, 4. Gen sample of a vector. That's this. Right. We have a vector of that. Okay, this is interesting because we just had a generator that worked and now we have a generator that does not work. So this, let's see. I messed up somewhere. So this generator, if we do a gen sample on it, it generates a list of single characters. It generates a list of single characters, right? Right. And then we want to map that to a join. We want to map that. We want to map that, which is this gen map, to string join. I wonder if it should be the other way around. Join join separator collection. No, that's fine. So this cables. This map has a gets a character which cannot be a sequence. It cannot be a sequence. It tells us it cannot be a sequence from Java lang character, which is exactly true. It's true. Should we make a vector here then? Alright. Alright, we fixed it again. So now it returns single character. I'm still trying to figure out how what it will do. What I want. Let's not make it more complicated. I want to also do the. It's almost 12, an hour and a half. I want to quickly dive into the mocking. But this will be interesting. I will write about it in my blog, I think. So we have this list, and we can see that now the test, when it runs, it will run 100 times, and it will make sure that all the combinations and the different lengths will result in a pattern being generated, and we can make sure that the pattern that we think is being generated. So the test check allows us to do this really nicely. We just we just saw that. Obviously, what we actually want is to not have a CSV string, but we want to have a generator that can create a given pattern and pass that along, or at least a string of a certain length. That's what I was thinking about. Generate a string of a certain length, which is this gen fmap, which is a nested. See, you think about a problem and you cannot get it out of your mind, right? Jeff, more string, and then instead of the gen alpha, we say CSV string. What am I doing here? Car alpha. We need to make this one. Car accepted. Car accepted. Right. Evaluate this. Evaluate this. Gen sample more string. Right now, there we go. String accepted. So we're breaking down the generator. So we generate a valid character, then we generate a string of a certain length of valid characters, and then we take the list that is being generated and combine that into a comma separated list. And that means that we can say, go back here, of string accepted, right? String accepted. So CSV string will now generate random length strings in random length combinations in a comma separate value. Beautiful. And then we can evaluate it, and it works. Beautiful. And now we can enhance this area with the characters accepted to have a generator that can also generate regular expression parts. So we can enhance this quite a bit. But let's leave it at that for now. So we know what we are talking about. Beautiful, the internet always works. And let's spend a little bit of time on mocking. What we need is ring mock. There we go, and version 0.3.0. There we go. Beautiful. Wait. So it was added nicely. Beautiful. And this case. So let's create a dev test API handler. We want to test our API handler, and let's just first start with is equals, and if we again pull up our API handler, which is in web server itself, API handler has routes. Let's make it a little bit bigger. A handler has routes, which goes through appdb for our Clojure for database connection. It loads resource from / and if it's not found, we'll return 404 not found. Oops. And the handler itself, this app, which has this connection to DB, which we might need to mock out, will call /question and /question ID. And what we see here, the dev test for the ring mock request, we need to include this ring mock request. Mock request. Okay, we can just call it request. No, that's okay. Called mock, because then everything is the same, right? What we need to do is to have our handler deal with a mock request saying get document this. And what is our handler? Our handler is the result of app, which is the result of handler. So we can call handler, but we need to provide a DB, and let's for now pass nil, because then fun stuff will happen. So equals, let's say system under test app, a handler with the parameter of nil, and this will actually have as a result a function. So we will evaluate the function, and this function will deal with our mock request. And our mock request will get /question, I believe. Question, right? And that will get us a random question from the database. So what it will do now, it will call the dev protocol db action get random question on our nil. So what will that do? It will probably fail miserably. I wonder what it will do. Let's check out what it will do. But let's just grab this ring result. It should have our expected result. Actually, I think we should have a failure of the first most massive kind. Let's see. The result is false, which is what we expect. What we actually get here is a 404 not found. Oops! And that is because we need /API/question. Okay, so we know our mock works, right? Our mock request, and this will actually give a 500 error because there was a big ass error here. No implementation of method get random question of protocol for class nil. All right, and now we have multiple things that we can do. Let's first make sure our 404 handler works, which we already did. Not found will result in 404. Does this matter? It doesn't really matter, I guess. Equals. It is false, and because we probably got a text HTML. Is the header relevant? Do we need to do the entire thing? Oh, that's cider eval last expect replace last expect to that one. Let's make sure that our 404 always works the way we intended it to work. So it returns HTML and the body will be 404, right? So when we update our 404 page, this will fail, but what we test is that we have a 404 handler, right? And that is exactly what we want. And here we will have application JSON. So the most simple thing that we can do is actually to create a test class that we can use for our protocol. So let's add our DB protocol, trivia.db protocol. It's called DB protocol. Create a def record. Do we need def record? Test fixture. And for now, let's just say that we have DB protocol / DB actions, I believe. And we have this get random question, and we have a correct answer, true or false. This is question ID, answer ID. And get random question, what does it return? It returns Postgres in memory is good, in memory database. It returns one of these, right? Which is not true, but because last week we made a change to it. So let's just grab this one, and we should actually see something that we broke last week and we did not realize we broke, I guess. Correct answer, true. Was it true? I think it was correct, true. So having this will mean no fields of factor given. What did I break? What did I break? Invoke. What did I break? This is actually just True. Oh, yeah, of course, yeah. Good morning. So let's evaluate that, and that will actually definitely a new test fixture. And for now, we will accept this as a viable so when we call new test fixture, we get this new test fixture on which we can call those functions. So nil would actually be, in this case, new series. My hand is still aching from that drive, right? New test fixture. So now we have a fixture that will have data, and that will mean that this will actually return an error. Interesting. Why does it give an error? Web server. We go to handler, which takes the database. The database is handler DB, which is the one passed along as DB, and DB system DB is actually the database Postgres, so that should be fine. Fine. So that should just call appdb that. So I'm wondering what the error is. It's also not very good at having an error. So maybe if we just do this, that works. What happens if we call db protocol / get random question on new test fixture? It returns what we expect. App. We do handler, right? We do handler, yes. So we're now in the debugger. In case you didn't know, the hashtag DBG allows you to start a debugger session when we run our unit test, or part of this test really now. We now see that this DB is actually test fixture, and I'm thinking the problem is actually this build course list. Now that I look at it, because this works, that works, moves down there, and then it will evaluate that part, that's fine. Then moves over to this one, env. That should actually work nicely, because our environment, our test environment, has this course set up. So it does wrap course, right? And then it goes out, and then I wonder what the error is. Maybe we can, so that actually it will probably move into this area as well. So appdb is here. We do this. Let's see if we can grab this one as well. Continue. It's fine. Why? You should no longer be right. I'm thinking. What am I thinking? The problem with this dev app is that this call here never. The debugger has a problem with this in the sense that it is called from an anonymous function, which is wrapped through all the macros and all the things. So let's make our life a little bit easier, and let's. Can we? Because we do all this logic within this Clojure basically. So retrieve question gets random question db, and we will actually define get random question db, and that basically becomes a pure function, which we should then be able to seriously, where did I start typing those? Right. So we should be able to debug this, see if this works. Yeah, so important lesson here is that we should aim to have pure functions that we can use from them using the debugger tools, etc., and not have all the logic within this context, which is probably a macro, which is nested in a macro. It becomes a mess. So now we can actually see what is going on. And we can call db, we call the function here, and that works. So what I'm thinking here is that what we're seeing is actually the thing that I thought would be going wrong anyways. If we remove this, because we removed the correct field, and of course we need a better way to read that, and I'm thinking if we read the body of the result set, it will be fine. Continue. So now it worked. Yes, it worked. All right, so let's first make it work, then we will fail it again and grab the result set, and then we will call it a day. Right, so it has a lot of stuff, and we want to check only a few things. Let's take a look at the API documentation. Set the body. I just want to check if the status was okay. It is actually entire structure, so what we can do now is say remove this and say status of this should be 200, and that should be truth, right? Yes, we can continue. That should be 200. We can remove the debugger here, evaluate that again. Somebody on my Clojure setup for Emacs video actually recommended binding ace window to Ctrl X, because now it is Currently I do not have it bound to a very sensible combination, and he recommended binding ace window to a contour XO, which is the jumping of the windows. So given this, I will do that. So this is truth. Evaluating this, we have functioning test cases. All right, so what we had here, correct, true, is actually the reason why our test case fails. And the reason why it fails is because we have something very interesting. We have an exception in the schema definition. So let's call this let result. Let's actually, we don't care about much of it. Keys, status, and body. Right, there we go. And then status should be 200. That is our check. Let's evaluate it, make sure that it still fails at the same reason. So what we want now is to log info body. Let's see what it does, right? It's okay, it will fail. And it says it is a buffered input stream. The body is a buffered input stream. So now we need to make the buffered input stream something that we can print. First attempt being a string, which is not what we want. So Clojure print buffered input stream. I cannot type. I'm still cold from the bike ride. Imagine how cold it was. In is it's quite interesting. What did it give us? The body is an object buffered input stream. So we want to read this buffered input stream. This is basically in IO, yeah. Input stream. Local IO. Writer binding. It's not entirely what I want. But I want buffered input stream to string. Slurp. Slurp. There we go. Of course. The most simple things. Some things in Clojure are so simple. It will fail. Yes, beautiful. And the result was errors, answers correct, disallowed key. So that was the thing that was hounding us. So we know that we failed. We failed miserably because we changed the API and our in-memory database, as we know, is not correct. So our in-memory database no longer works for the testing for the API. So we know we did this and we should fix it. But for now we have a test for it. And it works nicely now with our test fixture. If we do an integration test with the in-memory database, I will actually, since the time is already 12:15, I need to get ready to pick up my kid from school. I will do that offline and describe it in a blog post that I will link to the video. Next week there will actually be no live session. It is holiday season in the Netherlands, so we're out and we're going to do family things. So the next session will be the 28th, I guess. It's the 14th now, so the 28th. But I will not leave you with nothing during the holiday break. I've created some videos on using Cider in Emacs in an efficient way. We're actually discussing various aspects of it. So I will be releasing those videos during the week. It should give some nice insights into how to do various things. So if you liked it, press the thumbs up. If you have not done so, there's 80 people already that subscribe to this channel, which is awesome. If you have not done so yet, click the subscribe button down below. It's greatly appreciated, and I welcome any feedback on the subject and the things that I do. So thank you for watching, and see you the 28th, not next week, the 28th. Thank you and goodbye. Have a great day. Bye bye.